So today's session is also going to be a very extensive mathematical, or you can say that more conceptual things. First, like today and tomorrow also, we will build our foundation. We will build our foundation, and then we will see a demo. Okay. So like, let me just take this thing. So this is the deep learning. So in the last lecture, we discussed a simple how we can create the artificial neural network. So let me create a simple artificial neural network. This is x1, this is x2. We have seen that this is the hidden layer 1. And this is the output layer. So first of all, can you please tell me the how many trainable parameters we will have in this architecture? How many trainable parameters we will have in this architecture? Please quickly calculate the trainable parameters we have in this architecture. Okay, so 24, 25, 25. Okay, so let me just calculate, guys. So two, so this neuron will contain the two weight, one bias, three, three is 9. Then this will contain the one neuron contain the 3 input and one bias. It will be 4 trainable parameter, 4 3 is 12. And this neuron contain the 3 input, one bias. Total parameter will be 4. And then combined will be 25. This contain the B1 weight. So one operation is that we are doing the W11 X1 plus W1 to X2 plus B1 bias and put the sigmoid function. Okay, so this is the thing that we have. Now let's start the training process. So what is my training process? How we start it? So very first step is we initialize the weights. So weight or bias, you can say both things. So my first training process, in this training process, First is that we initialize the weight, or you can say like initialize the weights and bias. This is my first process. So basically, if you see these things, so now we will start with the few values of means we start with the some random value of the W11, W12, and other values. This is my first process. Then when we have decided, when we have set up the random values for the weight and bias, so definitely you can see that it will have some output. It will also have some output. This neuron also have some output. Again, this will pass, and their weight is also initialized. And so we get some calculation. So this will pass to next one. So now, after initializing the all the weight and bias, I will get the my p value, which is my predicted value. So corresponding to these things, after initializing the weight and bias, I will provide the input. We will provide the input and get the output and calculate, you can say that, and calculate the output. Okay. So this process, initializing the weight, provide the input and calculate the output, we call this process as a feed forward. Okay. So maybe somewhere here they also mention these things, the feed forward. So the feed forward process is your left to right. Your feed forward process is left to right, where we initialize the weight and calculate the output. So this process is my feed forward. Any doubt so far? Now, in the third step, what we have to do is we have to calculate the loss using the loss function. First step is calculate the loss using loss function. If you see these things, I'm also doing the same thing that we have seen in the regression concept in machine learning. So we are doing the same concept here. So based on my type of loss, I can use the sum of squared error. I can use the cross entropy loss also. Okay, so I can use this loss and calculate the loss anchored by the model. And now the fourth step is update the weight, update the weight, update the weight and bias and bias using optimization algorithms. And fifth step is repeat the steps repeat the above steps. So this is your training process in the artificial neural network. If you see this thing, it is pretty similar that we have. It is pretty similar that we have in the case of the linear regression. There also we initialize some coefficient, then calculate the loss, and then after that we update the weight and just follow the same training process. Okay, so if you have any doubt so far, please let me know. If you have any doubt, please let me know, guys.
Yeah, Harish, one question. So we said step number 1 and 2 is feed forward, and then step number 3, 4, they are called differently.
So you can say that 3 step is normal, and this fourth step, the fourth step, we call it as a back propagation.
Okay.
Back propagation. Okay, because now we will go in the backward direction.
Okay. And there are only two types of loss function that we use: SSE for regression and cross entropy for
Mostly,
class.
yes, mostly.
Okay. Okay. Thank you.
Okay. And now I'm just showing you all these steps using a. I'm just showing you these steps using a entire mathematical calculation, because most of the times like learners just want to see that how the things internally works, right? So I can show these things, I can show these things using the TensorFlow, the Keras library, but sometimes the learner are more interested to see how the things works in the algorithms, or they just want to see, right? So now I'm also showing the in-depth knowledge. So I request you to please pay attention, guys. Don't be sleepy, or don't just you can say the simple start the session and then you are moving here and there. Don't do these things, because this is the important part. If this you are able to cover if you're able to handle if you are able to understand these things, then the next part will be pretty easy. Okay, so now I'm just starting the a architecture. This is my input x1 and x2. I have the one hidden layer, and this is my output layer. And this is my output layer. I'm calling it as a H1, this as a H2, this one as a O1, output 1, and this is as a O2. Now I'm taking the input. I'm taking the input as a 0.05. This input is, I'm just writing these things because you have to do this calculation. So you have to be more attentive here. So my first value is x1 is 0.05, x2 is 0.10. And then after that, you are passing this value to the H1. So for the H1, your weight will be 0.15, and the second will be 0.20. Corresponding to this, your bias will be 0.35. I'm writing these things for you. You have to just use these things. Okay, this is the one. Then for similarly, this one for the H2, your weight will be 0.25. And for the last weight will be 0.30. Okay. And now you can call it the bias is also the same, which is the 0.35. First, if you see this, remember, if you see about this H1, we are doing this some calculation, and then I was talking about that we have to pass this information into the sigmoid function. Sorry, one sigma function, or you can say that activation function I was telling about. So if you see H1, so H1 is your W1 X1 plus W2 X2 plus your bias, and then I'm passing these things to the activation function. So here I'm using a activation function is sigmoid activation function. We will discuss these things also. I'm just passing this thing into a sigmoid function, which you already have seen in the logistic regression 1 by 1 to power e minus x. So first you have to calculate this calculation, pass this calculation in the x and calculate your output. So your H1 will be 1 by 1 plus e to power minus W1 x1 plus W2 x2 plus B1. Can you please calculate these things and give me the answer? This is your H1. Similarly, we will calculate the H2. Everything is on your screen. I have given you the formula as well. So please do these things and let me know.
0.593.
Let me check the calculation. So Manjali 0.299. Please check your calculation. The right answer is 0.59. The right answer is 0.59, guys. Hema Raju is give the right answer. Shiva Raju also right answer. Manish, check your calculation. Aisha, check your calculation. The right answer is 0.59. Okay, so the learners who are not able to do these things, let me just show the calculation. And then again, we have to do these things for the H2. Okay. So I show you the things, so I'm just showing the formula here. So it will become something like 1 plus e to power minus 0.15 into 0.05 W1x1 plus 0.2 into, this is my weight, W2 into x2 is 0.1 plus my bias is 0.35, and these things will come around 0.377. So in the next step it will be 1 plus e to power minus 0.3775, and if you calculate these things 1 by 1 to power e to power this one, the sum will be 0.5968. Okay, let's assume this one 0.5968. So H1 is coming as a 0.5968. And can you please calculate the H2 as well? So all the things is already given to you. Now just use the same formula and calculate the H2 as well. Everything is on your screen. Please use this formula and calculate the H2.
But H2 is 0.5968.
Sorry, yeah, this is your correct. H1 will be.
It will be 0.5932. The H2
Yes,
will be 596.
correct. Wait a minute. This will be 5932. And if you calculate the H2 will become as a 0.5968. Am I right? Can you please calculate these things? In the meantime, let me write down these things here. Please can confirm if the H2 is also coming as a 0.5968. Okay, great. So now I got this 2 value, means my first hidden layer is clear now. And now I'm just passing this value. So first we are passing this value. I'm passing this value to this one, and this is S1. Here the weight will be 0.40, and next weight along for the H2 is 0.45, and bias is you have to use the 0.60. Activation function will remain the same. Activation function will remain the same, which is 1 by 1 plus e to power minus x, or you can say the sigmoid function. Your activation function will remain the same, which is your sigmoid 1 by 1 plus e to power minus x. Please do this calculation and tell me the O1 value. Please calculate. I got only 3 responses so far. So value is 0.7575. Okay. If anyone is facing issue, please feel free to ask. Yes. Yeah.
Sir, what is this 0.40 and 0.45 in your output answer?
These are the random weights.
Yes.
Because we have to start the process with some weight initialization, right?
Yes.
Remember the training process. So we have to start the process with the random initialization of the weight. So this is my weight. Bias is 0.61.
Yes, sir.
So I'm just showing you this this one, guys. So the learners who are not able to
These
do
weights
things,
will always lie between 0 to 1 only. Or
generally we keep it 0 to 1. But we start with a random one so that we can start the calculation. Okay. And over the period of time, they will increase or decrease. Clear?
I mean, normally, these weights cannot be negative, right? This will always be positive, and that in the range of 0
So
to 1.
it can be negative also. If you remember in the TensorFlow playground, when I was showing you this website, you saw some weight as a negative as well, right?
Mhm.
So negative is also possible. Okay, so I'm assuming, let me just show you the calculation. I'm just showing you the output for the O1. So if I talk about the calculation for the O1, it will be 1 by 1 plus e to power minus, and it will be 0.4 into your H1, which was the 0.5932 plus 0.45 into H2, which was 0.49, which is 0.5968 plus your bias is 0.6. So after this calculation, if we pass the value into the 1 by 1 plus into e to power minus this one, your O1 will come as a 0.75. So any doubt in this one, the learners who is not able to do these things, please let me know if you have any doubt in this one. Almost everyone give the right answer. That's good. But if is there anyone who is not able to understand all this calculation and want me to calculate the things again, please let me know. So this class is for the everyone, guys. Don't hesitate. So if you are feeling that, Harish, I'm not getting the things, please feel free to ask me. Please unmute yourself and ask me. I'm not able to hear you if you're speaking. Okay. So my final call is like no doubt. And if there is no doubt, so can you please do the same thing for the O2? And for the O2, let me just wait a minute. So now for the O2 again, we have to pass the H1 and H2 with some weight. And this time weight will be W50, sorry, weight will be 0.50 and here it will be 0.55. So 0.50, 0.55 and bias, let's keep the same, which will be 0.60. I'm just keeping the bias, but it is not necessary that you have to keep the same bias. Bias can be different, but just for the calculation, I'm just keeping it same. So weight is 0.50 and 0.55. H1, H2 is coming. Do the same calculation and tell me the value for the O2. Okay, let me check the answer. 0.77, 7701, 0.7729. Okay. Yes, 0.7729 is the.
Good morning. Stefana,
Guys, please mute yourself if you're not speaking.
మన ఇది దేనికి మీటర్ కోసం అన్నది
Okay, I think everyone give the right answer. So now I got the now if I talk about the O1, we have seen that it is the 0.75, 0.751. And similarly, if I talk about the O2 is 0.772. So O1 and O2 is nothing but the predicted value for a class or some predicted values for the actual value. We have the predicted is 0.75. Let's assume that my actual value, what we were expecting for the O1 was 0.41. This is 0.01. A minute. The actual value which I was expecting is 0.01. 0.01 is my actual value for the for this O1, and for the O2, the actual value that I was expecting is remaining part, which is 0.99. So now this is my actual, this is my predicted, this is my actual, this is my predicted. So now I have these things. So what I have to do is I have to find out the loss. And if I tell you the loss, if you remember the loss formulas, so the loss will be, for this one, the loss will be 1/2 summation of your actual minus predicted square. These things you already have seen in the linear regression. So I'm just using the same formula. So if I use this formula, so it will be 1/2. Your actual is 0.01. Predicted is 0.753, and I'm taking the square of it, and the answer will come as a 0.27. Any doubt so far?
You'd add the error for the B2 also, and then take the average.
Sorry?
No. So this loss function, so this 1/2 multiplied by the loss
Actual
at
minus
B,
predicted.
that I mean O1 plus O2 loss, right? And then
No, no,
add both and then
as
take
of,
the average.
yes. No, as of now, I just calculate the O1 loss. O2, I will now calculate it.
But then this 1/2 comes only after adding these two losses, right?
Yeah, this is the formula that I think that we have. This is the formula that we have, 1/2 your actual minus predicted square.
That 2 is because we have two outputs, right? I mean, two.
Yes. Yeah, because it will help us in the derivative. Remember?
This is the formula for the last function.
Your voice, I'm not able to hear him properly. Is it for me only, guys, or can you hear
No,
the
no, for everyone.
Hema, I'm not able to hear you properly.
This is the last function, sir.
Yes, this is the loss
Uh,
function.
okay.
So this is the loss function that we have, 1/2 actual minus
Like
predicted.
this is like a MSC, like a mean square error formula kind of, little bit similar to that.
Yeah, it's a mean square error, right? Take the mean, or you can say it's a simple SSC, not the mean square error. This will be the SSC, sum of square. 1/2. If you see these things, we always 1/2 to make my derivative easy. So that's the one. Clear?
So how did we take actual values from random values?
No, actually, so I'm just assuming that my actual value was 0.1. So for example, I mean, when you have the two class, right? So I'm assuming that
Yes.
class probability was 0.01 and another class probability was 0.99. I mean,
So that
I'm just taking
yeah,
it.
we need to assume, right? So nothing will be given.
No. These things will you get in the data set. In the real time scenario, we don't need to assume it. These things you will get in the data set.
Acha, okay, sir.
Okay, you don't need to
Okay.
assume it.
Acha, for now, we are just doing to do the process. That's it, right?
Yes. I'm just showing you because now I'm just
Yeah,
creating a
thanks.
hypothetical scenario to show you the entire process.
Okay, sir.
Okay. So any other doubt? So if there is no doubt, can you please calculate the loss for the O2 as well? I calculate the loss for the O1. Can you please calculate the loss for the O2? Please calculate the loss for the O2 as well. It will be the same 1/2 actual minus predicted. Actual is 0.99, predicted is 0.772 square, and it will become as a 0.0. Please calculate these things and let me know if you are able to get the same output or not. Please let me know if you are getting the same output. Okay, that's good. Is there anyone who is not able to understand this process? Please let me know also.
Harish, I have one question here. Am I
Yes.
audible?
Yeah, I can hear you.
Okay. So when you calculate the loss, okay, so I mean, first we take the difference between the actual value and the predicted value for each of the output variable, and then square it, and then you do the average, right? 1/2. I mean, 1/n sigma
No,
of
it's
the
not the average.
values.
Actually, we do the 1/2 to make my derivative calculation easy. If you remember these things, you will see this thing in the loss function concept. So we are using this, actually the formula is the sum of square. SSC, I'm using the SSC. The purpose of the 1/2 is just to make my derivative easy. Because this is not the average. Average means that we have the two values. It's not the average. The purpose of the 1/2 is just to make your derivative easy for the SSC.
Is it not that I mean the mean square error, MSC or
No. Mean square error when you have the multiple values, right? I have the only one value as of now, right? It's not the mean square, it's SSC with your 1/2. Clear?
Yeah.
Okay. So I hope everyone is enjoying the lecture. So now let's start the next process. So I'm just saying that this I'm just putting some values like W this 0.0.1 0.15 was W1, it was W2, then we have the W3, this is my W4, this 0.04 was W5, 0.45 was the W6, and then this is my W7, 0.50 was my W7, 0.55 was my W8. So this is my entire process. So my feed forward is complete, and my second process, which is the calculation of my loss, is also completed. Okay, so we have this loss, and now I'm calculating the total loss. Now I'm calculating the total loss, and my total loss is 0.27 plus 0.029, which will be 0.29. This is my loss. So we have covered all these things. O2 is my 0.7277. So far we have done the two process. we have done the two process. One is my feed forward is complete. So my feed forward is complete. My feed forward is done. My loss calculation is also done. My loss calculation is also done. And what was the third step? Can you please tell me what will be the next step? What will be the next step?
Backpropagation.
Back propagation. So now we are going to perform the back propagation. So what is this back propagation? Again, back propagation is another algorithms. Now we are going to use this algorithms to update my weight, and in this back propagation, we internally use the gradient descent algorithms. So here we will use the gradient descent algorithms. So can you please tell me that what we have in this gradient descent algorithms? If you remember, we have some kind of a formula we have in the gradient descent algorithms. Can anybody ping me this formula in the chat section? All whosoever is, I mean, I'm expecting this thing from everyone. If you are aware of this formula, please post the formula in the chat section. This is very, very important to know. So please post your formula in the chat section. Please post your gradient descent formula in the chat section. Gradient descent is error minus into learning rate. No, yes, it is not. Deepika, this is the simple linear regression equivalent line. Guys, please post your gradient descent formula if you remember. Don't search over internet. This is not an exam. Whatever your thought is, please post your thought in the chat section. Okay. I'm not expecting a wrong and right answer. I just want to know that how many of you guys are aware. If you are aware, that is good. If you're not aware, it's still good. Okay. Don't try to copy the things from the internet. Let me check your answers. We take the differential. Okay. I think Aisha is also give the right answer. So if you remember, guys, the formula was, if I write this thing in the terms of the W, so it will be W nu equal to W current minus learning rate into derivative of loss function with respect to dW current. So this is the formula that we have. So this is the formula that we have. If I write down this formula in the gradient descent, and you know that the main thing is the derivative part, and derivative is just in the direction to minimizing the loss. So basically, if I plot a graph between loss function and the weights, so if the graph is like this one, so my main objective is to find out this minimum point, right? So with the help of the gradient descent algorithms, we are doing this kind of a calculations. Okay, so my objective is that if my iteration point, my loss is here, so my objective is to reduce this loss and reach out to the minimum point. This is my requirement. Now, I'm using some terminologies to just perform this calculation, make these things into the more formula wise. So I'm representing the E total, which is my total error in this equation will be E O1 output 1 plus E output 2, right? This is the E total. Basically, you already have seen that. And E O1 is nothing but 1 by 2 target O1, which is your actual value, minus your output of O1 of square. Your output of O1 is nothing but 1 by 1 plus e to power minus net O1, which is nothing but the calculation. I'm just using this terminology just to, and which was my net O1 is nothing but, if I talk about it in the terms of the weight W1, W2 things, so it was the W5 into output of my H1 plus W6 into output of H2 plus my bias. And which bias I was using is, like, for example, we are calling it as a B1. Okay, let's make it as a, this is as a B2 because this is my B1. So this is my B2. So this is, I'm just writing in the form of the some kind of a standard terms instead of the number. So now what my requirement is, I want to update the W5. Okay, so please pay attention. What my requirement is, to update the W5. So in this W5, my requirement is, or you can say that my objective is update W5. So if I update the W5 using the backpropagation algorithms, my formula will become W5 new is equal to W5 current, or you can call it as a simple, because this is the right current value is the W5 itself. So W5 new is equal to W5 minus learning rate into derivative of your loss function, where the loss is my E total divided by dW5. Am I right? Any doubt here? Please let me know if you have any doubt here.
This W5 would be some numerical value, the weight value.
Yes,
So
W5.
here,
Uh-huh.
yeah. Okay, then the derivative, right, that we are taking on the total error with respect to dW5, how will it work? Like, this is the constant, the W5.
Okay. So the thing is, like, if you remember your linear regression concept, so you are saying that your y actual is 0.5 and y predicted is 3 plus 2x1, 2x1, or you can say that it will be, wait a minute, it will be 3 plus w1, x1 value is 3 plus w2 into 5. So now this is the W1, W2, right? Although we have the value is some value is there, but in terms of the derivative, this is my equation. Am I right?
When you do that dW2, W2 will be replaced by the original equation which is used to calculate the
No,
O1.
yes, but this is my equation, right? If I talk about my equation, here my equation, let me put these things, okay? Let me put these things. You will get the things more easier. If I put this out one here, so can I call it as a my E total is will become very complicated to just write, but let me just write down these things and let me know if you are able to understand. So my E total, I'm not putting the W5, I'm just writing the equation, okay? Then we will take the derivative. So it will be, my E total will be 1 by 2, then target 0, 1 is my point 0, 1, minus E out is out 1 is nothing but W5 plus out H1 plus W6 out H2 into out H2 plus B2, then it's square, right? Because now I'm just taking the derivative of W5. In the terms of calculating the derivative, this will be my equation of line. And now I have to just take the derivative of in terms of the this value. W7 plus out H1 plus W8 out H2 plus B2 entire square. So this will be your loss value in terms of the W5 and W6 and W7, W. And now I will
Can you
just
explain
take the equation with the help of
W5, W6? What are the things?
yes.
Sir, can you explain what is this W5, W6, W7, W8? Because
Yes. These are my weights. These are the my weight equate. These are the my weights. So W5, I put it for the weight coming to the O1, and W6 is this one. W7 is for the O2, and W8 for the means W7, W8 for the O2, and for the O1 is W5 and W6.
Okay, sir. I got it.
If you remember the equation, right? So I'm not doing anything extra here. If you remember that this is how the equation will also, the same thing that you also have seen in the linear regression. In the linear regression, when you are calculating the loss function, your loss function will be y actual minus your equation will be somewhere like 3 plus W1, X1 is some values for the one iteration. Like for example, X1 is 1. This is your W1 plus W2 is your you can call it as a like X2 is as a your 4, and then this is your X square. So if you do the X square, it will become like Y actual square plus 3 plus W1 2 plus W2 4 square plus 2 into Y actual into 3 plus W1 2 plus W2 4. Am I right? Right? And if I want to do this calculation using the, if I want to do this calculation using my formula, if I do, like for example, this is my entire loss function. If I do the dl by dw1, so this will become 0. Am I right? Again, these things you have to first again calculate these things, and then you have to take the derivative. And similarly here, it will become the only 2. It will become the 2 into y actual. This will become 0. 0 plus W1 is 2. This will also become 0. So this is the derivative, guys. If I ask you the derivative, let me just ask you these things. What will be the derivative? So y is equal to 6x3. Can you please tell me the derivative of dv by dx?
18x square.
Yes, tell me.
18x square.
Yes, 18x square, right? So this is the same thing I'm doing here also, right? So I'm just writing the equation in the form of the W1, W2, W3, and now I'm just calculating the things. But here, while doing the back propagation, we found a small problem. Let me tell you the problem, guys. Let me tell you the problem. There is a small problem is we have a small problem, and problem is my E total. Can you please tell me that my E total is in the function of the, before that, let me give you one more example. So can you please tell me the derivative of sine x squared? Can you please give me the derivative of dv by dx of sine x squared? Then you will able to understand this concept. Y
X into cos x square.
y is equal to sine x square. So can you please give me the derivative of dv by dx? Everyone, based on your knowledge.
Sin x whole square, yeah, sin x square.
Okay, tell me. Okay, let me check it in the chat section. Okay, put it in the chat section. One of the learner mentioned that 2 sin x cos x. Okay, 2 sin x cos x. Don't check it over the internet, guys, because we are not checking any wrong on the right answer. If you are aware, you can simply put the things in the chat section.
Is this sin x square or sin x whole square?
Sin x square.
So then it would be 2 cos
You
x
can
square.
put in the chat section.
Sorry, sir, I misunderstood to be sin square x. So 2 sin x cos x is not right. I'm sorry.
Okay, so Hema is mentioned that 2x cos x square. Aisha is mentioned as a minus 2x cos x square. Okay, please paste your answer in the chat section, guys. I just want to see that, like, whether you are aware or not. Otherwise, like, I will also, I mean, in any sense, like, in any way, I will cover the things also. But I just want to know if you are aware of these things, then it is good. And if you're not aware, then it is also good. Okay, so let's start the next. Okay, so the thing is that my y is equal to sine x square, and now I want to perform the dv by dx. So my y is directly depend on the sine. My y is in the function of the sine, and sine internally depends on the x square. So if I do these things, if I do the dv by dx, we have to perform the chain rule of differentiation. Am I right? Yes or no? Yes or no, if you are aware of this concept, right? So to calculate this sine x square, I have to perform the chain rule of differentiation because my y is not directly depends on the x square. So how the things will work is, first I have to do the dv by d sine, and then into d sine by dx, like this things. So dv by d sine is keeping this x square as another variable, so it will be cos x square into this one d sine by dx, which is your this variable. So x square derivative of x square will be 2x. So the answer will be 2x cos x square. This will be my answer. So the main thing that I want to highlight here is my main motive to highlight the things here is just this chain rule of differentiation. We call it as a chain rule of differentiation. Okay, so same concept I'm going to implement here. So the problem is that my E total, if you see my E total is depends on the E01 and 02, O1 or O2. Internally, this E01 is depends on the out O1. This out O1 is depends on the net O1, and this net O1 is depends on the. So this is the chain rule that we have. Please let me know if you understood this concept. My E total is depends on the E01 and E02. If I take about this E01 is internally depends on the out O1. Out O1 is depends on the net O1. Net O1 is depends on this calculation, which is containing the W5. So this W5 I have to find out. So if I want to calculate the D total by W5, this chain rule I have to follow. Please let me know if you are able to get these things. Please, everyone, if you are not able to get these things, no problem. You can tell me that, Harish, please repeat these things. I will also repeat the thing.
Harish, can you repeat how are you using chain rule here? So chain rule I could understand, but then how are we using it here?
I will explain you this.
Sure.
You got this thing, right? E total is dependent on the E1, right?
Yes.
You can say that E total is the function of E01 and E02. Correct?
Yeah.
Then E01 is the function of out O1.
Correct.
Out O1 is the function
of net O1.
net
Yeah.
O1, and net O1 is the function of W5, W6. Correct?
Correct.
So now if everyone is able to understand these things, so Rahul, please repeat. So now it's clear, repeat. Rahul, I also repeated these things. Now it's clear to you, Rahul? Okay. So now I'm going to write the main thing. Please pay attention. Please pay attention. I'm going to write this chain rule of things. I hope you guys are getting the things. If you feel any doubt, any question, please feel free to ask. If you feel that, Harish, you need to improve your teaching style, if you want anything from my side, please feel free to post your suggestion privately to me as well. I will not feel annoyed. Okay, so please, if you want me to improve anything from my side, so please feel free to post in the chat section. Okay, yeah. So now I want to calculate the D total by DW5. So we will follow this hierarchy, this chain rule. So now just please pay attention. So I want to calculate the DE by DE total by DW5, because this is my requirement, because I know the W5, I know the current value of W5. We can put some value for the learning rate. The main thing is the DE total by DW5. So if I expand this DE total by DW5, first I have to calculate the DE total with respect to D out 1, D out O1. If you see these things, I'm just following this approach. I will first calculate the DE total with the D out to O1. Then D out O1, we are calculating with the D net 1. And now this net O1 is depends on the your O5 dw. This is the chain rule of differentiation. If you have any doubt, please let me know. Okay. So now let me just do some little bit more mathematics. Any doubt, guys? Please, yes or no? Because if you are not able to digest this mathematics, I can just skip this part. Okay. My main intention is just to show you the things, how the things going internally. If you feel that this is too much mathematics, so I can just skip this part. Please mention this thing in the chat section, guys. If this is okay to proceed, I can proceed more mathematics. If you feel that that is okay, we can skip. So you can mention the skip in the chat section. If you want me to okay, so learners are mentioned that more mathematics is okay. So I'm assuming these things. The everyone response is that Harish, go with the more mathematics. Why I'm telling you this thing, guys, because sometimes in the interview they ask very depth things, so you should be able to explain this one. So now, if I talk about the E total formula that we already have seen that, so it will be target value, target O1 minus out O1 square plus 1 by 2 target O2 minus out O2 square. I want to calculate because I want to calculate these things now. So this thing is E total divided by E out 1. So this value will become 0, guys, because this is this doesn't contain any out 1. So this value will become 0. Yes or no? Quickly, guys, please tell me these things. This is the constant value because this doesn't contain the out O1. So these things will become 0. Tell me, guys, quickly. This will become 0, right? Right? Because this will become the constant value. So this will become the constant because this is not the function of out O1. So that's why constant, and derivative of the constant is always 0. And these things I'm just calculating quickly. So this power of 2 will come here. So 2 divided by 2 into target O1 minus out O1 into this one. If I target O1 will become 0 and this minus out 1 will become minus 1. And now this formula 2 to power 1 is this will become minus of target O1 minus out O1. Target of O1 was 0.01 if you remember in the part, and out 1 that we calculated is 0.751. If I calculate these things, so my answer will be 0.741. 0.741. So this is we have calculated. So this things comes as a 0.741. So similarly, I will calculate the E out derivative of out with respect to the net one. Okay. So this is okay, guys. Any doubt here? Similarly, now I have to calculate the derivative of E out O1 with respect to the derivative of net O1. If you see these things, the formula is O out 1 is out O1 is, the formula is 1 by 1 plus e to power minus net O1. So if I talk about this formula, if my formula is y is equal to 1 by 1 plus e to power minus x, so dv by dx will become e to power x divided by 1 plus e to power x. So if I use this derivative, so it will become, it will be minus, guys. It will be, because power will come, right? Minus, it will be minus. Okay. If I calculate all these stuffs, so if I use all this calculation, so it will be, my comes out to be 1.1. So this is my E out by E net. Similarly, what I have to do is, I have to do my net O1 is my W5 out H1 plus W6 into out H2 plus B2. And can you please tell me the derivative of E net O1 with respect to DW5? Can you please tell me the output? Can you please tell me the derivative of net O1 with respect to DW5? Okay. Tell me, guys, I got only one response. So I need to calculate the net O1, derivative of net O1 with respect to the DW5. Please give me the answer quickly. What will be my answer? What will be my derivative value? Okay, out. Yes, guys. So it is simple. If you are because other parts are not in the form of the W5, so this will become 0. This will become 0. This is also constant, become 0. And W5 out 1 is your out. And your out H1, if you remember that your out H1 was the 0.5932. Now I'm putting all these three value into the formula. So E DE total with respect to DW5. So I have written these things that this will be considered as a D out 1 into derivative of out 0 1 net 0 1 into D net 0 1 DW5. Right. So the first thing that we have calculated is 0.741. This thing is now we have calculated is 0.186. So this is 0.186. And the last thing is we calculated right now, which is the 0.59. If I do this calculation, it will become the 0.08. And now if I go back and implement these things in the formula, so my formula that if you remember that DW5 new is equal to DW5 minus learning rate into derivative of E total divided by EW5. So the current value of the DW5 is your 0.4. You have seen that. Learning rate is assume learning rate is your 0.5. I'm just assuming it, okay? It can be anything else. So now the learning rate is 0.5 and this D total by D5 is 0.082. If I do this calculation, the new value of my DW5 new will come out as a 0.359. So this is how we update the weight. Similarly, this is my DW5 new. Similarly, you can calculate the DW new, D7 new, DW8, sorry, W8 new. Similarly, in the deep level, you have to calculate the DW1 new. Similarly, W2 new. Similarly, W3 new, and similarly W4. All these weights are getting calculated, the new value. So now I will update this value in my architecture, in my network, and recalculate the calculation. So this is the iterative process, and we are doing this calculation and get the value.
Sir, I have a question like, how did you get 0.186 in
How point
D out differentiate by D net 1?
which
Can
one?
we go up, sir? Slide up.
Yes.
A bit up, sir. This one's the 0.186. How did we get this one, sir?
0.0181 is you were coming from this one, right? D out by D net, where the out was 1 by 1 to power e to power minus x. So I'm just putting these things, I'm putting this thing in my formula and getting this value. Okay, if you got it right.
No,
So,
no, sir, I didn't get it. See, because the numerical value is 0.186. So how did we get it? My question. So do we have any value for e to the power of x?
so definitely, see, I have the formula is 1 by e to power minus e to power net 1. X is nothing but net O1, right?
Yes, sir.
So dv by dx is come as a e to power x divided by 1 minus e to power minus x, correct?
Correct.
If I put the e to power net O1 divided by 1 minus e to power net O1, then if you put these things, you will get this formula. This will get this value.
Okay, sir. Now I got it.
Okay. Let me know if you are able to. So I just followed one step and show you the entire calculation from first is initializing the weight, calculating the loss, perform the back propagation, and update the weight. If you see these things, I followed the one entire steps. So definitely it's not possible to calculate the each weight. So the way that I
So
have
this net
calculated,
O1 is the output of O1?
yes,
Sir, this net O1 is the output of O1, right?
can you please speak loudly?
The net O1, sir, say we have written the formula as
Net O1,
net
right?
O1 by 1 minus net O1. Yes, yes, yes. So the O1 is the output of this one, right?
You're talking about you're writing this one, right?
Yes, sir, yes, sir, yes, yes, yes,
Yes.
yes.
Net O1 is the output coming from the O1, right? Before
Okay,
implementing.
so for net 1, we need to calculate this. Weight 5 into output of H1. If we do this formula, we get the value of net O1.
Correct.
So we substituted the value of net O1 in the differentiation, like e to the power of net O1 by 1 minus e to the power net O1, right?
Yes, correct.
Yes, now I got it, sir. Thanks.
This is a chain rule, right? That's why we are calling it as a chain rule, because one thing is dependent on the another thing.
Yes, sir. Yeah, because it's a bit confusing. We are doing it
No,
for
no,
first time, right?
yeah. No, first time it is I can understand these things. So let me do one thing. Let me just reiterate the things, and then we can wrap up the session for today. I hope you found the session is helpful for you. If you have any doubt, please feel free to ask. Okay. So in this today session, we decided to learn about the learning of this artificial neural network. What is the training process or the learning process? You can say that. So we took a simple example. We start with the what is my training process. We saw that my training process start with the initializing the weight and bias, then provide the input and calculate the output. This both two process is collectively called as a feed forward. Then in the third step, we have to calculate the loss. And then after that, in the steps 4 and 5, we have to update the weight. So we took a very simple example where we are using the two inputs, one hidden layer and one out layer. We start with some random weights, and then after that, we start performing the training steps. So first we just follow the same approach. The approach is that we calculating we are using the 1 by 1 plus e to power minus x, which is your sigmoid activation function. And then after that, we have to use the sigmoid activation function to pass my linear combination of my weight and bias and perform the things. Then after that, once my output is ready, corresponding to this predicted output, we call it as a predicted output because this is prediction from my model based on the weight and bias. So now I have correspondingly, we have the actual values and corresponding, we have the predicted values. I will just use the loss function SSE and calculate the loss. Once calculation the loss is done, we have to perform the backpropagation, and we saw that in the backpropagations, we internally use the gradient descent. So first we saw the formula. First we saw the formula, and then after that we start implementing this formula. And then we just found that in the formula of my backpropagation or the gradient descent, we are using some derivative, and when we start implementing this derivative in the my artificial neural network, we found that it will be solved by the chain rule of differentiation. So we saw this chain that my loss is dependent on the out O1 is dependent on the net O1 is dependent on the function of W5. My requirement was to take the to update the W5. So I just use this chain rule of differentiation, calculate the things separately, and after that put into the formulas. After putting these things, I found the new value of W5, which is 0.359. Earlier we have the 0.4, so my weight get updated. Similarly, we will update the other weight and just create the update the all my new weights again, and again this follow this predict the output and perform the loss and this process. So this process will keep going until we get the minimum loss function.